So I went through and I found the questions from our last two quizzes, and so we're going to do this today, and we're going to do it our next live class as well, just to go back and sort of review and discuss the questions and the answers you guys got. But I pulled the ones that were most missed, so not all of them, just most missed. This was all on the calculator active. So this guy, I'm not 100% sure where we all went wrong, but as I've said many times before, I would start with making sure you know your great divide. I know this question is always giving kids like a headache a little bit because there's fractions and there's all the parentheses and all the fun stuff on it as well. But if we want to, you definitely want to do PEMDAS, so parentheses first. So 1/2 is the same, multiplying by 1/2 is the same as dividing by 2. And we talked about that last week. So multiplying by 1/2 is the same as dividing by 2. So 1/2, or you could type this in your calculator, obviously, because this is calculator active. There has been some in the past on the inactive portion with the fractions of 1/2 and 1/3, but all the numbers are divisible by that number evenly when it's calculator inactive. So 1/2 would be 3. And then we're going to do 1/2 of negative 24, or minus 24. So we're going to do minus 12. Now when we get to the other side, again, you got parentheses again. So it's going negative 8 times k, negative 8k, negative 8 times a negative 1 is going to give us a positive 8, because a negative times a negative is a positive. Then we have a positive 11 times k, so it's going to be plus 11k. And then 11 times 4 is going to give me 44. So just orders of operations, you do want to distribute first all the way through. My suggestion at this point is to combine like terms and clean up on each side before you start crossing the equal marks, because the adding and subtracting and the inverse operations is where a lot of mistakes happen. So I have a constant and a constant. So that means 44 and 8 are going to give me 52. And then negative 8 and a positive 11, so those guys are matching. So negative 8 and positive 11k is going to give me 3k plus 52, and this guy's still hanging out over here. Now, we want to get our k's on one side and our constants on the other. So the number without a variable needs to be on one side, and the numbers with the variables needs to be on the other side. So we can move that 12. That's a minus, so the inverse would be adding. So we add. So I have 3k equals 3k plus 64. I'm going to subtract 3k from this side to get it over the other side. Now, we run into a problem, because if I have 3 and I lose 3, I have 0k equals 64. Now, if I divide by 0, you can't divide by 0. It's not allowed. So that means at this point we're at no solution. There's no way that we can make this equation work. So because it's 0, 0, dividing by 0 is a no-go. So that's how you know it's a no solution. Now, if it happened to be 3k plus 52 and 3k plus 52, or 3k minus 12 and 3k minus 12, and the whole thing, they match on both sides, that's all real numbers. So if you get them down, they match perfectly on both sides, and everything zeroes out, your constant and your variable, that's all real numbers. But when it's just the variable that zeroes out, then it's no solution. So when variable zeroes out and that's it, it's no solution, because there's nothing I can multiply 0 by to get 64. But if it's 0k equals 0, so they both cancel out, then it's all real numbers. I did notice a lot of the word problems, so like the sentence structure is what messed you guys up too, because they were missed in both, in the active and inactive. Which sentence represents the equation 3x minus 5 equals 14? So I think what would be best is we do 3 times a number. So a number is x, times is multiplication. So that means we have 3x. Is 5 less than 14? So is 5 less than 14? 3 times a number is 5 less than 14. 5 less than is subtraction, and that comes after, this part moves to after the 14. 5 less than $14. So hopefully, I saw a lot of people do 5 minus 14, but that's going to be a negative 9, whereas we're actually 5 less than $14 in your pocket. So that's not it. And then 5 less than, so that's going to be minus 5. And then it's less than, so 5 less than what we're trying to, goes in the front, what we're taking the 5 away from. 3 times a number, so that's your 3x, is equal to, is 14. And we're going to keep going down. 3 times a number less than 5. 3 times a number less than 5 is 14. 3 times a number less than 5. That one actually is going to be a mess because less than 5 would be an inequality in that case. 3 times a number. Or we could do 5 minus, but maybe that works the same. 3 times a number less than 5, so that would be minus, is 14. 3 times 5, 3 times 5 less than a number, so that's x minus 5 is 14. So 3 times 5 less than a number is 14. And so our answer is going to be B in this case, because that is 3x minus 5 equals 14. And it is a little harder to figure out sometimes to get the words in the right order. I think it's just basically practice. But more importantly, the consistent mistake I saw was it was 5, and then you saw less than, and you just put a minus. So 5 minus 3x. And that's not how that works. Less than means it goes after the number that it's referring to. Okay. I did see some questions on some of the ed puzzles and the end of the surveys on percentage of scores. So I was excited that this did show up to be a problem so we could discuss it. Now, no matter what this looks like, how big the boxes are on the inside, how wide one of the tails are, or if they're even on either side, each one of these segments is 25%. No matter what. Like even that tiny box is the same as this big box. So your minimum, your Q1, Q2, Q3 max, all breaks it into 25% of all the data. So what percentages of scores were above 75? So 75 is going to be right here. And above is going to be this way. So that's 25, 50%. So 50% of our scores are above 75. If it was to ask what percent is below 60, so I would go to my 60, and below is going to go this way, so that's going to be 25%. It's kind of hard to get through. You just have to memorize it that no matter what it looks like, those 4 chunks are all 25% if we're looking at percentages of data. They fall in there. Because remember when we wrote it all the way out and we cut it in half to find our median term, then we cut the left side in half and then the right side in half again. So we cut them into 25% little chunks when we were doing it long-handed as well. So each box and each tail is going to always be 25%. Always be 25%. All right, inverse operations. So I'm a little concerned with some of the conversations I saw on some of the ed puzzles on this. So inverse operations. So for addition, to undo addition would be subtraction. And I drew my arrows going both ways because to undo subtraction is addition. If I have to multiplication, or if I'm multiplying, to inverse multiply or undo multiply, it's going to be divide. And then vice versa. To undo division is going to be multiply. The other one I want us to learn is to square a number. So that's when x is squared. To undo that, we're going to take the square root. And the sooner we get it through, the better. And that's the one, that's the root bar without a number in it. Just for those who are paying attention. So if I was to cube a number, to undo it, I would do the cube root, which means, whoops, that would be an x there, sorry. There would be a 3 in the little ditch, not 3 times the square root, but it's actually taking the cube root. So what number times itself 3 times would give me the number under here, whereas this is 2 times because it's squared. All right, so then look at this problem. Like when we were doing our solving our equations together in live class and in your notes, great divide, box in your stinky kid, we want to move that negative or minus 22.5. So that minus is the same thing as plus and negative. So this is a negative. So to undo a minus or undo a negative number, we have to add. And when I say undo, that's because we want it to become a 0 on this side. And then we have to do it to both sides because that's how you can maintain the value of those numbers in this equation. So we're going to add first. So letter A is bad because that says subtract first. We don't want to subtract because that would just give us a negative 45 on this side. Or negative 44. Yep, negative 45. And then to multiply would be close, but the subtract part is wrong. So we're going to go to add. So subtract and then divide is what's happening right now. Subtract and then divide. If you're trying to do it inverse, maybe at best, that might be why we chose that answer. That was a popular answer. But we know we have to add first. Once we add to both sides, we end up with x over 2 equals 124.5. That's x divided by 2. And again, the inverse of division is going to be multiplication. So we're going to multiply both sides by 2. And just for practice, we're going to go ahead and solve it. So that's going to be x equals 249. Yeah, 249. So I was doing it in my head. 249. So then we did that by multiplying. So it's going to be add and then multiply. So our answer is going to be C. Because if we divided, that wouldn't make this any better. Dividing, that'd be like multiplying by 1/2 is the same as dividing by 2. So we'd end up with x over 4. We wouldn't be getting rid of the denominator here and getting x by itself. So we want to make sure that we know that we add and then multiply, because we add is the inverse of subtraction and multiply because it's the inverse of division. Another conversational question, again, back to writing word problems. 2 more than a number is equal to 6. So 2 more than a number. Again, more than a number. It means the 2 kind of comes after if you want to teach yourself a consistent. So 2 more than a number is equal to 6. So this would be 6 more than a number is equal to 2. 6 more than a number is equal to 2. You could say 2 plus a number is equal to 6, or in this case, it's the same thing, because when you add, it doesn't matter. 2 plus 3 or 3 plus 2 is still 5. When it's subtraction, it does matter because that starts getting into positive negative games. So this is going to be our correct answer. This is 2 times a number. The product of 2 and a number is 6. 2 times a number is 6 or equals 6. And this would be 2 times a number plus 2, or 2 times 2 more than a number equals 6. There could be lots of ways this last one could be written in lots of different sentence forms. But your answer for that one would have been the x plus 2. And maybe I'm hoping the reason we got confused is because it was 2 plus x instead of x plus 2. But again, addition can be interchangeable like that because it's going to always equal the same thing. Subtraction cannot. Division cannot. Multiplication and addition, they can sort of rotate seats, I like to say. But I got a lot of 2x equals 6 answer in this one too. Remember your vocabulary. More than a number is just addition. This would have had to have been like a product or 2 times a number. So we got to make sure we remember the words that mean addition, or remember the words that mean subtraction, multiplication, and division. So it's a vocabulary study game. If that is something we need help with, I need you guys to let me know, because that's not really Math 1 stuff, and it would be extra for me to tack it on in a lesson, other than just like conversationally like this. All right, so we're going to keep the second page for Thursday, and we're going to work on some inequalities. All right, so I got a couple just basic ones to try first, and then compound is what you're going to start tomorrow. Today you were working on multi-step inequalities. So again, just like multi-step equation, you can think about this as the great divide again. Either side, you see parentheses, so you do want to distribute first. So 5 times a negative 6 is going to give me a negative 30. B. Then 5 times a positive 2 is going to give me 10, which is less than a negative 200. Hopefully when you see that less than, you think open circle already, like we've gotten that through our head. If there's not an equal to, it's going to be an open circle. So we have our stinky kid, And on the outside is at plus 10. So how do we undo adding 10? The inverse of addition is what? We're going to subtract 10 from both sides. That gives me a negative 30b is less than a negative 210. Good job, good job. And now that negative 30b, that's a negative 30 times b, so that's multiplication. And the inverse of multiplication is going to be division. Now, this is that golden rule. So ding, 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 pay attention, star, star, star. We just divided by a negative. And remember, the golden rule says if you divide or multiply by a negative, then we have to flip the sign. So because we divided by that negative 30, it's going to become b is greater than, so we have two zeros, so we can cancel those out in our mind for a second. 21 divided by 3, it's a negative and a negative, so it's going to become a positive 7. So b is greater than 7. We're going to do a test point where we take that 0, which in this case on our line would be over here, just for thought process. Is 0 greater than 7? And that's not true. Having no money versus having $7 is not greater than, not better, right? So we're going to go to our 7. It's going to be an open circle. There's no equal to, so we're not going to color it in. And 0 is not greater than 7, so we're going to color in the direction away from 0. And if 0 is doesn't make sense to you as to why you would want to use that as your test point, you could pick either number like on either side of your 7. So is 6 greater than 7? No. But is 8 greater than 7? Yes. So you want to color in the direction of that test point. Like you're just picking a number to decide which direction. Like I mentioned in our previous class, b is greater than. As long as your variable's on the left side, I have seen teachers teach that you color in the direction of the arrow, but it has to be variable inequality number. So it's not consistent all the way through our higher level math. All right, so we're looking at the next one. I did this one as a little bit of a trick because your variable's on the wrong side, quote unquote, wrong side. But we're not super stoked about when the variable's on that side for most of you guys. All right, so we're going to distribute first. Negative 4 times a negative 7. So 4 times 7 is a negative times a negative is going to give me a positive. So negative 4 times 7 is going to give me a positive 28. And this guy's just going to hang out over there. Then we're going to do negative 4 times 3b is going to be a negative 12b. We have our stinky kid, which is at negative 12b. 28 is attached with the subtraction in front of it. Like that is an addition subtraction. Like it's not 28 times a negative 12b or 28 divided by a negative 12b. It's a positive 28. So to undo that, we're going to subtract 28 from both sides. And that's going to give me 28 to 30, 72. And then a negative 12b. Hopefully a little alarm's going off in your head because negative 12 times b, the inverse would be division. And we're trying to undo the negative 12 times b. So we're going to divide by negative 12. Ding, 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 ding. Divide by, so again, this is going to be that golden rule of inequalities. We're divided by a negative. So 72 divided by a negative 12 is going to give me 6. We're going to flip that sign because we divided by a negative. And that's going to give us b because that's going to give you that positive 1 on that side that you were looking for. And these guys become that 0, which is how we get to that negative 12b. So we're going to go to 6. Oh, negative 6. Sorry, negative 6. There is an equal to. So we can color that bad boy in. And now you want to do a test point. So 0 is going to be over here. That's the one I like. Is 0, so negative 6 less than or equal to 0. Is negative 6 less than or equal to 0? It is less than 0. If you want to use the numbers there, you could do is negative 6 less than or equal to negative 8? It's not. Negative 6 is better than negative 8. Owing someone $6 is a better deal than owing them $8. And then your other one could be negative 6 is less than or equal to negative 4. And you don't have to do this many test points. I'm just showing you so that way you understand if 0 doesn't make sense in your brain. Is -4 greater than or equal to -6? Or if you read left to right, is -6 less than or equal to -4? It is. So again, 0 and -4 are true. So we're going to color in this direction towards our 0. All right. Number 3 is a little different, so we're going to keep going. So number 3. Again, we have a number, our great divide. Let's see if we can keep ourselves on either side so we don't do any magic math and start making stuff up. I'm going to distribute first. The -6 times a +1. It's going to give us a -6. I have a -318. It's less than or equal to -6. -6 times 8b. So negative times a positive is going to give me a negative. And 6 times 8 is going to give us 48b. Then we have -4b. Now, this is another one of those where I suggest you clean up on each side because we have 2 like terms on this side. -48b and then a -4b is going to give me a -52b. Because if I spent 48 and I spent 4 more, I'm spending 52 total. So that's negatives. -318 is still over here. -6 is a constant, so we want to get it away from our b in this case. That's a -6, so we're going to add 6 to both sides because that'll turn that into a 0 on this side. And whatever we do to one side, we have to do to the other side. So if I owe you $318 and then I pay you 6, I owe you $312. -52b, that's negative times b, means we're going to divide by -52. Divide by -52. Ding, 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 ding. This is our golden rule of inequality, and I didn't mean to do all of these this way, but it's good practice. Because we divided by a negative, we're going to flip the sign when we're done, but 312 divided by 52, and they're both negatives, so our answer is going to be positive, is going to be 6. We're going to flip the sign the opposite direction. So 6 is greater than or equal to b. So we're going to go up to 6, start a circle. And then we are going to decide, is there an equal mark? There is, so we're going to color that in. And then we're going to choose a test point. So 0 is over here. Is 6 greater than or equal to 0? It is. Or like I said, you could try 5 and 7. Is 6 greater than or equal to 7? Because that would be coloring towards the right-hand side. 6 is not greater than 7, so that's not good. And then I guess you can check 6 is greater than or equal to 5. That is true. So 5 and 0 is working. So we're going to color in that direction. So color in the direction where our 0 is and in the direction where our 5 is. Because 6 is greater than all the values. So ultimately this is stating that all numbers less than 6 will make this equation true. Like if we were to start plugging in numbers and trying to find a number that made it true. So maybe they would say, is 9 a solution to this inequality? And in that case, it's a no because 9's not colored in on this side. Is 2 a solution to this inequality? 2 is colored in, so it is a solution to this inequality. So all the numbers, 3.75 would be a solution because it's on that side between 3 and 4. 9.5 is not a solution because it's not colored in on that side. All right, so then we'll do number 2 again. So some more practice, just more practice. Do number 4, I'm sorry. 2 times 7b. It's going to give me 14b. 2 times 1. It's going to give me 2. And please notice that I'm doing an arrow, writing down some math. Doing an arrow, writing down some math. If you happen to make the habit of doing the arrows and then doing the math, you will skip whatever step you were going to skip if you didn't do the arrows anyway. So each one of those arrows is making sure you give, I like to say, pass out that 2 candy bars to every person if it was to keep going in your parentheses. But so as you draw an arrow, do math. As you draw an arrow, do math. Again, we're going to get our 14b by itself. That's addition of 2. So the inverse of a positive 2 or addition of 2 is going to be minus 2. So I have 14b is greater than or equal to, I owed you 110, and then I spent, because it's in the negative, I took away 2 more, which means I owe you 112. In this case, that 14 is positive. We are going to divide because that's 14 times b. But it's a positive, so the symbol is going to stay the same direction. So these guys go away, and b is going to be greater than or equal to whatever 112 divided by 14 is. And that's a negative divided by a positive, which means I'm going to have a negative as my answer. So negative 8. It's a little helpful, too, when you look up here and all your numbers are negative, in case you got a positive 8 and you look up. Probably good chances that you made a little boo-boo on your positive negative signs here. So negative 8. So we're going to go to our negative 8. Come back and look, is there an equal mark? There is. So we're going to color him in. In this case, 0 is going to be this way because it's negative 8, negative 6, negative 4, 2, and 0. Moving to the right. So I'm going to test, is 0 greater than or equal to a negative 8? Having no money in your pocket is way better, or is greater than owing someone $8. So 0 does work. If you just want to prove, is negative 10 greater than or equal to negative 8? It's not. You don't want to owe people more money if you can help it. It's definitely not greater to owe people more money. So we're going to color in the direction away from that negative 10 because it is not true, or towards our 0 because it did make it true. So again, at this point, they could say, is negative 12 a solution to this inequality? So is negative 12 a solution to this inequality? And your answer would be no, because it's not colored in that direction. Is a negative 4 a solution to this inequality? Your answer could be yes, because it's on that solid line, the colored in line. Is negative 8 a solution to this inequality? Would be yes, because it has the equal to. Had it been just greater than negative 8 and there was an open circle, then negative 8 is not a solution. It has to be solid circle. Okay, solid circle has to be. Now, I got 5 minutes, so this is going to be quick. We're going to do one of each. So we have ands and ors, so compound inequalities. And so you can take Sally and Tom to the park with you on Saturday versus you can take Sally or Tom to the park with you on Saturday. And means you can take them both, or means you have to take one or the other, right? So your directional of coloring is going to show the same thing. And that might not make sense yet, but hopefully when I'm done showing you these, it will. So this first one, we're going to take our equation. So 9 plus 2p is less than negative 9. And we'll just put a pause on this guy. Just like we were doing before, we're going to solve it. Get 2p by itself. That's a positive 9. So we're going to subtract 9, subtract 9. So 2p is less than a negative 18, because I owed you 9, and I owed you 9 more, means I owe you 18 altogether. 2 times p, we're going to divide by 2. We divided by positive, so everything's fine. We do not have to switch our sign because we divided by positive. The answer is negative, but that's no big deal. It's if you divide or multiply by a negative. In this case, we're positive, so we're still good. So p is going to be less than negative 9. So p is less than negative 9. I'm going to go, making sure I do my math right. Yep, so that'd be about right here. It's not an equal to, so you don't want to color it in. P is less than. 0 is on this side. Is 0 less than negative 9? Like I said, having no money in your pocket is better, greater, than owing someone negative 9. So that's not the right direction. So we're going to go in this direction. And then we're going to go look at our second equation. So 10p minus 7 is greater than or equal to 13. Got our big great divide. Stinky kid, or our 10p. We have minus 7. So to undo minus, or the negative, we're going to add 7 to both sides. So 10p is greater than or equal to 20. 10p is 10 times p, so we're going to divide because division is the opposite of multiplication. Remember, you guys are going to be so tired of hearing me say that. P is now greater than or equal to 20 divided by 10. They're both positive, so it's going to be 2. There's an equal to, so we're going to go up here to our 2. There is an equal to, so we're going to color it in. And then you can test your 0 again. Is 0 greater than or equal to 2? It's not, so we're not going to color towards 0. We can try a 4 just to make sure. Is 4 greater than or equal to 2? It is, So we're going to color towards the 4. So this way. So for ORs, it's always going to be in 2 directions. So you're going to be going out like this. So from 2 numbers and then out. So again, we had an open circle because there's no equal to, closed circle because there is equal to. But this is a compound inequality OR. Okay, so that's our OR. Again, for sake of time, I'm going to skip number 6 because it's the same thing, and you're going to have lots of practice tomorrow on this as well. Ands are different. Instead of going in 2 directions and you have to choose the 2 tails, and means there's going to be an overlap. And the only part that you're going to see is your overlap. It can be written with an and in the middle, and you're going to do it just like you just did the OR. You're going to have 2 equations. But what I've watched students get really messed up is when they write it like this. So I'm going to do this one with you guys. So negative 38 is less than or equal to negative 8 plus 6n. Stop your sentence. Okay, so don't panic, but stop right there. So we're going to do negative 38 is less than or equal to a negative 8 plus 6n. That's our first equation. And negative 8 plus 6n is less than or equal to 16. So the center, whatever's in the center, just repeats itself. And then you have your 2 inequalities with whatever the output is. And they don't have to be just numbers in the middle being your binomial. It can be mixed up. Your variables could be everywhere. But whatever's in the middle repeats itself. So 2 times. So we're going to solve this one, and then we'll solve the next one. So our great divide, 6n. We're going to add 8 to both sides because that's a negative 8 plus 8. It's going to give me a negative 30 less than or equal to 6n because I owed you 38 and I handed you 8. 6 times n, so we're going to divide by a positive 6. We're dividing by positive, so the symbol stays exactly the same. Even though we are going to have a negative answer, you don't flip your sign. These guys go away, so n, and then it's negative 30 divided by 6 is going to give me a negative 5. So we're going to go up to our negative 5, open a circle. If there is an equal to, so we're going to shade it in, and I'm going to use a highlighter just hopefully so you can see the overlap that I'm talking about. So like if I use a yellow, and maybe I'll use a green, or yellow and a blue. So negative 5, is negative 5 less than or equal to 0? That's I'm testing this side. Yes. Is negative 5 less than or equal to negative 6? No, because remember when you're moving to the left of the number line, they're getting less. To the left it is less. So we're going to go in this direction, and I'm just going to go about that far. You can go all the way down if you want, but your answers are not going to show like that. Typically on most of your multiple choice questions that you're going to see, and most of the formatting, they don't do them that way. So we have 6n. I have a negative 8 again. So I'm going to add 8 to both sides, same as last time, because we're just trying to get it off this side with our 6n. So 6n is less than or equal to 24. 6 times n, just like the last one. We're going to divide by 6 because it's the inverse of multiplication. Those 6's are going to go away. N is less than or equal to 24 divided by 6. They're both positive, so we're not switching our sign. Everything's great. Positive, positive is going to give us a positive. So n is less than or equal to 4. So I'm going to go up here to 4. There is an equal to, so I'm going to color it in as a solid dot. I'm going to test my 0. Is 0 less than or equal to 4? So is 0 less than or equal to 4? It is. Just for conversation's sake, is 5, which is the other side of that 4, less than or equal to 4? It's not. So we're not going to color to the right. We're going to color in all the way to the middle. And then you would stop. So again, all of these numbers will fix this one. All of these numbers past the dot will fix the first one. But what they're looking for is what will make both of them true. And that's everything between negative 5 and 4. So greater than, so n is greater than is usually an or, whereas this is like your less than symbols are usually your ands, if that helps at all. I don't find that always, I can come up with excuses in my head why that rule doesn't work. So I usually just solve them and then see it and then color in the appropriate direction. But again, don't panic if it doesn't make sense yet. You got lots of practice problems tomorrow and lots of notes tomorrow.